Planet 9 may not exist after all, new study suggests. Astronomers have been searching for a massive Planet 9 out beyond Neptune and Pluto for the last couple of years, finding it rather elusive considering that it is estimated to be about 8 times the size of Neptune. But there could be a simple reason for the difficulty in finding the planet: it doesn't exist. And scientists believe they know how to explain the evidence pointing to the possibility of a Planet 9. A new study using computer modeling may have uncovered an explanation for the orbiting perturbations of the 6 aligned objects, known as the trans-Neptunian objects, in the outer solar system, the odd eccentricities that have driven the search for a cause, or agent, of such mass and gravity, a massive Planet 9, as to account for just such an orbital alignment. Known as diffusion, the process is generally used to explain natural occurrences in the real world where, as it is defined by Michelle Bannister, a research fellow of planetary astronomy at Queen's University Belfast, Ireland, in the conversation, it is a random movement of a substance from a region of higher concentration to one of lower concentration, such as the way perfume drifts across a room. Bannister's computer model showed that a related form of diffusion could be the cause of orbits of minor planets to become altered from an ellipse ranging from 730 to 2000 astronomical units, or larger, and then return. As an example, she and her colleagues used SY99, a recently discovered minor planet that orbits far out beyond Neptune and takes 20,000 years to make one revolution around the Sun. That minor planet can be at various stages along its path relative to that of Neptune's. But when SY99 and Neptune are within close proximity of each other, Neptune's gravitational pull can exert influence on the minor planet's overall orbital route by changing its velocity. The alterations, whether making the elliptical path longer or shorter, is known as a random walk. And it takes place, the diffusion itself, over a generous arc of time, tens of millions of years. Bannister and company found the same alterations, but on a much smaller scale, on several of the trans-Neptunian objects. By extension, the study concluded that diffusion could act on some tens of millions of objects circling the Sun in the far reaches of the Oort cloud, that enormous shell of icy objects that orbit at the limits of the solar system. The diffusion, over time, could see trans-Neptunian objects shift in their orbits closer to Earth. Still, as Bannister pointed out, diffusion does not explain the orbit of far-away dwarf planet Sedna, which is so distant as to not be affected by Neptune's gravity. But it is a plausible explanation for the trans-Neptunian objects moving sunward from the inner Oort cloud. The upshot: no Planet 9 is needed for the phenomenon to occur. This, of course, does not mean that the Planet 9 is not there. But if it is not, then diffusion is a plausible explanation for why it might appear that minor planets and objects are aligned or orbiting in the manner that they do. As was reported by the Inquisitor, in a follow-up search for the elusive giant world, Scott Shepard of the Carnegie Institution for Science in Washington, D.C., and Chadwick Trujillo of the Gemini Observatory in Hawaii announced last August that, although not a slam dunk, they were somewhere like 80% sure that there's a Planet X, Planet 9, out there. It was Shepard and Trujillo who had posited the latest theory that Planet 9 might not only exist but showed astronomical evidence that might lead to its eventual discovery. That was in 2014, and the search was on. While telescopes have scanned the skies for the planet, others have worked on other aspects of its possible existence. In January, 2 scientists from New Mexico State University suggested that Planet the 9th of May have not originated as part of the solar system. Instead, they found it very plausible that Planet 9 was a captured rogue planet, a passing world that had been pulled in by the immense gravitation attraction of the solar system.